What is up, people, and welcome back to the mini sprint build. I couldn't remember what it was then. Right, so where we got to on the last one was we got the spiny, right? That's the start of the spine. So this time, what I need to do is we want to join, I've took a bit of glass out of here. We want to tie the subframe mounts into the cage, right? Now, it's easier said than done because this being a fiberglass shell, I can't take this as square. I've decided what I'm going to do is I'm going to hack the back of this off, fuck all this body off. And I've had a word with Les from Custom Minis, and this heel board, he says, is going to be between 5 and 8 millimeters thick. Right, so I've decided what I'm going to do is I fitted that, which is basically just bracing the centre spine to the floor. Then this is a nice fit. It's not pressed fit, so it's just holding the cage where it is. Then I've tacked these two little bits of box section to my table, and there's two holes in the subframe, and I've put 10mm bolts through and then welded them to the box. Now I've unbolted the subframe. Now basically, when I move that subframe away, once I've cut these sections off, I can then put the subframe back in exactly the same place, because the subframe, the front and back subframe, are square and true to my table, right? Because we need to get, the cage can be slightly out of square, and the body can be out of square, but the subframes need to be parallel. They need to run true with each other. So they need to be straight that way, as in the centre of this subframe is in line with the centre of the back subframe. They need to be true that way, so they are both running across. A lot of it is numbers. It's a numbers game. So that back subframe, I know, is square with my table, and it's where it should be. I've done the measurements. And the front one is square because it's on my jigs. So what I want to do is cut that off, take the subframe away, cut that off, the subframe back, do a few more measurements. But I know then that is going to be pretty square, right? So then what we can do is I'm going to make a packer. I'm probably going to go 8mm, if I'm honest. Because if I go 5mm and they end up doing an 8mm floor, I don't really know much about fiberglass, if I'm honest. But if I go 8mm, it's only going to bring the back subframe in a little bit more, yeah? So what we'll do is we'll make 8mm packers. Then we need to make a plate that goes in there to tie these bolts. And what I'm going to do is I'm going to break this back off, and then I'm going to put a tube from the plate to this tube. So it's all going to be a really nice strong corner, both sides. And I'm going to use the subframe as my straight edge, right? So that's the plan. Yeah, I think that's the plan. So we need to drop the subframe off, hack the back of the floor off, put the subframe back, check our measurements again. Then we need to make up some plates for the thing, and then break off the bottom of the feet of the subframe. Then we can parallel the feet of the subframe up to the floor better. Right, let's get cracking, shall we? Right, let's just catch up on what I've done. So the back's cut off. Chop, chop. That's out the way. I've retaken these feet off, cleaned them up. This is bolted to our standoffs we made. The back spaced up, so this is square with said table. Yeah, and we know that this is square with said table because I put it in. So right, what we need to do now is we need to make a plate for here. Now I was originally going to tie it into this, but I'm not sure now because when they make the new floor, basically this could be at a slightly different angle to the new floor, right? So what I don't want to do is I don't want to set this at that angle and it not fit flush with the new floor. Well, if I tie this in to this mount for the radius, the subframe, it's fixed. And then when they pull the floor up, it's going to put the floor under tension. So what I might do is I might leave this, I might pop another tack on it. Once I've positioned it where I want it, then if they need to pop this off to make fine adjustments to the bottom of the cage, because they can just pop the cage back out and make fine adjustments to the bottom of his leg to get this to sit at the correct angle of the new floor. Now, as I'm explaining this here, it sounds a better idea. So instead, what we're going to do, we're going to make the plates for mounting the subframe, and then we're going to tube them straight to the cage with another. This is 45 tube, so I might do 45 tube again straight off, so it's going to be nice and strong. I've got a big plate of 3mm, so we're going to make them out of 3mm. Right, so what we need to do, we know the angle of the floor because it's this. That angle there, going down like that, because that's the inner sill and that's the outer sill. So we can use that to get our bottom angle sorted, yeah? Because this also needs to be high enough that it's not going to contact the fiberglass. So we've got to make sure that it is going to be very tight because of this corner and this bolt. It is really tight. But look how thick the fiberglass is there, look. I mean, look at that, that's massive thick. Because this was all that was holding the rear subframe. If you have a look at what I've cut off, I mean, there is quite a lot of weight in what I've chopped off, to be honest. So what we need to do then, we need to design our plate so I know I don't want it sticking up. Do you know what I mean? Ryan, let's crack on with that, shall we? It should be really quite simple. And up here I've dug out the measurements. Right, so we've got our from centre bolt to centre bolt, which is 50.5 inches if I'm right. P 50.5 inches, which is like 1230 millimeters or something like that. And then up here, L is 2.25 inch, give or take 10. So I can make the plates correct. So what I'm going to do is I'm going to make the plates correct to the drawings, because this subframe, for some reason, the holes have been overalled out. Yeah. So we're going to make the plates correct, hold in the right position, spread the right distance apart. Then that's where they're going to go. All I'm using the subframe for is its distance. You get me? Because it needs to be there. Right, I'm going to crack on and let's just get this shit done. Right, so what we've got is two of these. Now I've changed this angle slightly, yeah? Only a little bit, look, but I changed it because I've gone with the angle of the subframe, not the floor, to allow a little bit of clearance. So when this is in line, see, we are in line with the subframe. Yeah, so instead of going with the floor, I went with the subframe. So now what we need to do is we need to get these holes in the correct position, which is a bit tricky considering we don't quite know where these holes are going to be. So I don't want them, they've got to be far enough in to be strong, but not far enough in that this sticks out way past. So what I'm going to do, I think, is measure the full width of the subframe from there to there, on the other side, and then we'll get a bit of a, we could come in an equal amount to get to the right dimension, which we know. Get me all that, the other paperwork, which will convert for me into einen millimeter. So I didn't get it out yesterday, did I? I only got this one sheet out for some reason. I keep paperwork with dimensions and all sorts of stuff. You've got to have it here. It is actually 1282 width between centers, rear subframe, front mounts. So that's center to center is 1287. So we should leave that on there. So 1287. So if we get einen, oh, tape measure. Hang on, this could be easier on my own. I'll just rest it there somewhere. Right, so it's a little bit awkward now considering I've got those stanchions sitting there. One 1305. Yeah. I'll just hook that there, hook that there. We have 1305. So what do you think? 1305. Yeah. Now I'll take a measurement from the inside to the outside, which is 23 mil. And then the other side, this is just to make sure the holes are in the same place. This one's going to be a bit more awkward because it's backwards, so ruler 23 mil, exactly the same. So we know now what we can do is we can get our 13. Where's my notepad and a pen? So it's all about maths, isn't it? It's all about numbers. So we've got 1305. And we want 1282. So we've got 1282. 8 takes us to 2. It's 90. 18 takes us to there. So 5, 8, 9, 10, 23. So we've got 23 millimeters in, haven't we? Difference. So we need to half that, don't we? Which is 11.5. Yeah. So 11.5 in. From each side is the center point. So from that we can determine, we now know where our holes need to be. So the plate, the end of the plates, from this end to the other end, need to be 1305, and the center hole needs to be 11.5 millimeters in from the end. That gives us our center to center. Right? Right, and let's get some... I'll just take it over. I can't remember. Center punch. So we'll pick a center punch out of my drawer of bits and bobs. We'll have this one. I'm sure I've got the big hammer out because I had it earlier. Right then, we're going to knock these center punched 11.5 millimeters in. Will be the center of our bolts, and then coming down from said bolt. L 2¼ inch So 2¼ inch down. So 11.5 in, 2¼ inches down, square. Right then, I'll get that done. Right then, so what I'm doing here is I've squared these plates up. They're slightly out. So we now square to this inside face, because that's where the holes are going to go, yeah? Both the same plates. So we know that we need to come 11.5mm in. So what I do is get my vernier, set it up 11.5, just drag it up, yeah, both plates. That's where we know the centre of our holes are going to be, yeah. So we know our centre line for down. Now we need to mark our 2¼ inch. Now 2¼ inch is what, 57mm? Let's have a look. 57mm. So we need to look at this 57. So right, hang on, let me just write my 57. 57. I've got to get a smaller ruler. Can't keep working around with this thing. So 57mm, and our line is 80mm. So we've got 80, 57, 58, 59, 60, 70, 80. So we've got 23mm, haven't we? Difference. So if we come in 11.5, what's the odds of that? Hey, what is the odds of that? So if we come in 11.5, top, 11.5 the top. What's the odds of that being 11.5 and 11.5? But now I'm going to come down, just so we know it's right, 57mm. Because that's on an angle. I mean, let me just scribe. Yeah, and then we want to double check that we are 57mm. So that's 58. It's because of the angle, isn't it? So we'll come from here, right in that corner. $55, $56, $57. Yeah, we were at 58mm. So there is one and there is two. Two. And that is 56.84. I think we can live with that, can't we? Yeah. So technically we could just drill through the pair to make them perfect. I think I'm going to. So. I also need to work out what bolts I'm going to put in. Right, so I've decided I'm going metric. So I'm going to put M10s in this. So for that, I'm going to put 10 on, and I'm going to weld them on the back. Yeah. There we go. Right, yeah. M10s. Our M10s Right, so now we've got our M10s. Yeah. Now we're going to do is weld them in situ. Backing plates. Right, we're at the lathe. What I've decided to do, you'll have to seriously ignore the mess of the lathe because it's just terrible. I'm going to make some spacers. I'm thinking if I'm doing all this work, but there's still going to be a weak point, which is going to be the fiberglass between the subframe and the mount I'm making off the cage. So what I'm going to do is make spacers. So basically they will put, basically I'm going to drill this out, M10, and I'm going to make them, he said 5 to 8 mil, the thickness. So if I go 8 mil, then this will protrude through the fiberglass, making it solely reliant on the cage, not the fiberglass. Because fiberglass can compress, and we don't want that over time. We want solid from the get-go. So I'm going to make some of these 8 mil M10, and then what they'll do is they'll open up, this is 20 mil, they'll open up the fiberglass to a snug fit 20 mil, pop these in, bolt the subframe on. So it's still going to be holding the shell snug to this. Understand? Right, I'll get these knocked out, shall I? We need 4 of them. Right, so we have our 4 spacers that we've made, 8 mils thick. So what we're going to do is, so the fiberglass is going to be drilled and the fiberglass is going to sit in this area. But this is going to be taking the load. This is a 3 mil. So now we've got to make our tube. So what I'm going to do is notch the end of this to 45 mil. Notch both ends. And then we've got to cut them to length, slide them down, tack them in. Right, so yeah, just get on with this then. So we've got to set this up for 45 mil. And we'll drop some notches in. Right, so now we've got our 2 45 notches. We've got to make it fit down there. So what we're going to do is take a measurement from here to here. 35 mil. Yeah, technically 35 mil should be what we want. So if we cut there, what we'll do, we'll go a bit bigger to start with. Chop it off. We should be able to slot that down there. You've got to get yourself one of these. I know this cuts square. So we know we want 35. What we've got to make sure is if we go much, we can chop it off. Should give it an extra couple of mil. That's all we want to do. Oh. Woo! Warm. So we are a tad oversized, which we know, don't we? We've also got to notch this one side for this. That's why earlier I fully welded the back side of here. Yeah, we're about a mil over. Right, so what we got is this. Yeah, we've got some good tacks on there. So we ain't going to go anywhere. And scoot, scoot, scoot round the other side. Another one. So I've got some good tacks in them. And you ain't going to go anywhere. So now, that technically is fixed to that. So now they can come out. But I'm not sure yet what I want to do next. But I think for today, I'm going to call it a day on that bit. And then we're going to do the seats. But they're going to be in the next video. Because the video is getting a bit long. And I've looked through and it's like people losing interest, like 10 minutes. So, Ryan, thanks for watching and I will see you in the next one. See ya.